We need to find out the area of a triangle whose vertices have the coordinates given by A, B and C. We'll also need to determine the length of the altitude through A. Now let's begin by first supposing the triangle as having vertices A, B and C. Now A has the coordinate -2, 1. B has the coordinates 5, 4 and C has the coordinates 2, -3. Now first thing, we'll try to find out the area of this particular triangle. And since we are provided with the coordinates, we can easily find out its area. If the three vertices of a triangle have the coordinates x1, y1, x2, y2 and x3, y3, then the area of the triangle is given by this particular expression. So let us begin. So first, what we'll do, we'll assume that our coordinate A that corresponds with x1, y1, B corresponds to x2, y2, and C corresponds to x3, y3. However, the choice of the coordinates is totally up to you. It's independent of choice here. And now let's find out the area. So area is going to be equals to half multiplied to the absolute value of, so we first need x1. So x1 is going to be -2. We have -2 multiplied to y2 minus y3. So that's going to be 4 minus -3. That means we have 4 plus 3. Then we need x2. So x2 is positive 5. So we have 5 multiplied to, we need y3 minus y1. So y3 is -3 minus y1. So that's going to be -1 plus x3. So here x3 is 2. So we have 2 multiplied to y1 minus y2. So y1 here is 1 minus y2. So that's going to be -4. Let's find out this value. So this will be equals to half multiplied to, so 4 plus 3, that's 7. 7 times -2, that's going to be -14. Then we have -3 minus 1, that's -4. -4 times 5 is going to be -20. Then we have 1 minus 4, that's -3. -3 times 2 is going to be -6. Now, -14, -6, that's -20. And -20 and -20, that's going to be -40 over 2. Or we can simply consider 40 over 2, that's going to be 20 square units. So that's the area of this particular triangle whose coordinates are known. Now our goal will be to find out the altitude through A. From point A, we are going to drop a line touching the side BC at D, and that's going to be the altitude of our triangle. And we need to find out the length of the altitude. We know the area of a triangle, it's given by half times base times altitude. Now in your case, since we are considering the triangle ABC whose area we have just now found out as 20. So 20 will be equals to half multiplied to the base. So the base is BC and we need to find out the altitude, which is simply AD. Now we can also find out the value of the length BC. We can apply what is known as the distance formula. So BC will be simply equals to, we'll take the square root. Underneath the square root, first we'll take the square of the difference of the x coordinate, then add it to the square of the difference of the y coordinate. So the difference of the x coordinate means we need x3 minus x2. So that will be simply 2 minus 5 whole square. And added to, we need the difference of the y coordinate. So that's going to be y3 minus y2, which is -3 minus 4. Fine. Let's compute this value. So this comes out to be, so we have 2 minus 5, that's -3. Squaring it gives us +9. Then we have -3, -4. So that's going to be -7. Squaring it gives us 49. So we have square root of 58. So now that we have the length of the altitude, length of the base as 50 square root of 58, we'll substitute it here. So we get 20 equals to half times square root of 58 multiplied by AD. So AD is going to be the altitude whose value we need to find out. So AD is going to be, so 2 times 20, that's going to be 40. So we have 40 divided by square root of 58. So that's going to be the length of the altitude.